Hi, in this video we're going to go over Worksheet 7.3. So let's take a look at things here. So first up, we got, let's see here, sorry about that. We got this spring in a cart and it's going over this loop-de-loop, very similar to, again, the one from the physics journal. And so first thing I like to do is take a look at this picture here and just decide what kind of energies we kind of have going on. So we got a spring that appears to be compressed. That's going to give us elastic energy. Then we have a cart and it's going over this loop-de-loop. So let's think about that. The cart is up high, so that's going to give it gravitational energy. It's also moving, so that's going to give it kinetic energy. A lot of times, some of the most difficult parts of this is trying to figure out what kinds of energy are involved in each situation. And that's how you kind of figure out, oh, okay, there's a spring that's going to give you elastic energy, or up high that's going to give gravitational energy, kinetic moving that's going to give you kinetic energy. Okay, so as we look at this, we have to think about what kind of things are we going to include in our system. Well, we're probably going to have the spring in the system because right, it appears to be compressed there, and that will give us zero elastic energy. And then we also have the cart that we'd probably want to put in the system as well. Initially, we start out with elastic energy, so we just have to put energy in the elastic energy. It doesn't really matter how much we put in there. I'm going to put 4 bars of energy in there just simply because that gives me options down the road to split that up. I could put 3, I could put 2, just gives me some more flexibility. Over at the end, my final energy is gravitational kinetic energy. It doesn't really matter how many I put in each one, just as long as they add up to 4, because that's how many put in the elastic energy. So I'm going to split it up half and half, 2 and 2. However, again, I could split it up however I wanted to, as long as it adds up to 4. And I have energy in both of those. Now, the reason I chose 2 and 2 is just because it gives me some flexibility for this next one, for example. This next one appears to be pretty similar. We got elastic energy here. The cart, again, is up high, so it's going to give it gravitational energy. It's just not quite as high, and it is also moving as well, so that's going to give it kinetic energy. Initial situation hasn't changed at all, so that's going to give me elastic energy. Again, my system won't really have changed because it's basically the same situation here. And then at the end, I need to think about this. So the cart's not quite quite as high. So that means it's not going to have quite as much gravitational energy. So I'm going to just put 1 bar in gravitational energy. However, it still does need to add up to 4, because it's got to add up to the number of bars that I had in the elastic energy. So it's going to give it 3 kinetics then. And that actually makes sense because it's probably going to be going a little bit faster, because as that cart goes up the ramp, it's going to slow down. And so since it's not all the way up at the top, it'll probably be going a little bit faster. So that ultimately makes sense as well. Taking a look at number 3, we have this car that's basically coasting up a hill. So it kind of gives you these little these pieces of information. So y equals 0 tells you that the gravitational energy is 0. Y naught or V naught is greater than 0 tells you that the kinetic energy is greater than 0, so that you do have kinetic energy. And then the V equals 0 at the end tells you that you don't have any kinetic energy because you're not moving. And that your gravitational energy, Y is greater than 0, tells you that you do have some gravitational energy, right? Gravitational energy is not equal to 0. I don't see, right? We have, as we think about what should go in the system, it appears to be basically just the car. There's not anything else that we would need to necessarily put in there. So we know that at the beginning, it's going to have some gravitational energy. Again, I'm going to start us off with 4 bars. It could, I could do 2, 3, or 4. It doesn't really matter. But again, as always, it kind of gives me some options down the road. However, it turns out that I don't really need to take that into account, because let's see here, we get to the end. Right, no kinetic energy because it says it's not moving. Yes, gravitational energy because it's up high, and no elastic energy because it's not moving. And as long as I say, oh, this is a frictionless hill, which I get to decide that, then no energy would be lost. Obviously, if you decided there was some friction, then you'd have, like at least one come out the side here, and then, um, sorry about that. You'd have one come out the side there and then just decrease your gravitational energy by one. So that would be an option. These both, I'm just going to go ahead and say these both should be frictionless as well. They don't need to be. Obviously, if you did that, then you just reduce your kinetic by one. Okay, moving along. Number 4, a person pushes a stalled car to get to the gas station. So here we have basically no energy of any sort, right? Not kinetic energy because it's not moving, not gravitational energy because it's not up high, not elastic energy because it's no spring. So basically E equals 0, like there's no energy there. Here, it's moving, so we're going to have some kinetic energy, get no gravitational energy because it's not up high, no elastic energy because it's not moving. So the question is, like, where did that work or that energy come from? Well, the person added that, right? So let's see here. We want the car to be in the system, but we don't want the person to be in the system, because what we want is energy to come right from the person. Um, and the reason we don't want to put the person in the system is because if you put the person in the system, then you have to like identify what kind of energy do they have in the initial side here. And we don't really want to do that because, right, a person is complicated. They don't have kinetic, gravitational, or elastic energy like stored up that they could use to push a car, basically. So at the end, we know that the car is moving. Again, the car is not up high. There's no spring, so no gravitational or elastic energy there. Moving along to number 5 here, it's given us some hints here. It says that both the height is 0 and the velocity is 0. That tells us that there is no gravitational energy, and there's also no kinetic energy. At the end, it's obviously up high, so we know that we have gravitational energy. We also, it says V is greater than 0. We also have kinetic energy, so we're going to have some sort of combination of gravitational and kinetic energy. Here we can see that there is a spring, so that tells us we do have elastic energy. So we know we're going to start out with elastic energy and end with gravitational energy and kinetic energy. Sorry, up here, we'll say that's frictionless, so we're not losing any energy to friction. You could, obviously, one would come out right here, and then you just reduce your kinetic energy by one. Okay, well, we got a spring there. We should probably put that in the system so we can have our elastic energy, plot that on the graph, and then probably just the block brick. I guess it's a brick, huh? Brick. Okay, so we're going to start ourselves out with elastic energy. Again, I'm going to start us out with 4, so that allows me to split it up if I need to later. And then I'm going to go ahead and I'll just do half and half. Again, it could be any combination that adds up to 4 or adds up to the number that you put in the elastic energy. So again, I just did 2 and 2. So, all right, moving along. A crate starting at rest is propelled up a hill by a tightly coiled spring. I'll remember ahead of time that I'm just going to make this frictionless, so I don't have to deal with that losing friction. V naught equals 0 tells me the kinetic energy is 0. Y naught equals 0 tells me the gravitational energy is 0. So I'm going to start out with just elastic energy. Up here, V is greater than 0 tells me that I do have kinetic energy, and I'm up here on top of this hill, so I am going to have gravitational energy. Let's see here. I got a spring, and I got this crate, so I'm going to put the spring in the system. And I'm also going to put the crate in the system. Those are the two kind of main objects there. So again, it's going to start out with elastic energy. Since I said it's frictionless, we don't need to pay any attention to that, to energy coming out. But again, if you said there was friction, you'd have like one coming out of here, and you could take it out of either side. It doesn't really matter. Now I'll go ahead and split it up 2 and 2. Again, it doesn't matter how you split it up as long as it adds up to 4. So you could have 1 in gravitational, 3 in kinetic. Again, adding it, as long as it adds up to however many you put in the elastics, then that would be fine. All right. So we got this bungee jumper falls off a platform and reaches the limit of the stretch cord. So if we think about this, the person is up high, so it's going to start out with gravitational energy, and then when they're all stretched out here, they're going to have elastic energy because you have a bunch of energy stored in that bungee cord. So let's see here. I'll put the person in the system. And I know that previously I've said, oh, you can't put people in the system. But again, remember that if you could replace that person with like let's say like a sandbag, then you can put them in the system. And in this case, right, it would be, you could just push a sandbag off the bungee cord and it would all work the same way. And so you're allowed to put this person in the system because they're not interacting with the system. They're not like adding or subtracting energy from that system. And so you can put them in the system then. I'll put the bungee cord in there. So bungee cord, I guess. So there we go, right? So we're going to start out with gravitational energy, and then we'll end up with elastic energy. So if you wanted to have some energy lost, to air resistance, or you wanted to have some energy lost to stretching, you could do that. That would probably be a bit more accurate. I'm just going to do 4 and 4, kind of assuming that energy is conserved here. However, right, in reality, probably right, you're not going to bounce back all the way up to the top of the platform. So therefore, obviously some energy is lost somewhere along the way. So yeah, you could do it that way if you wanted to. Okay, in this one I am going to say there's friction. We need to, I suppose I should read it to you. But Superman stopped a speeding locomotive, is pushed backwards a few meters in the process. So, obviously if he's trying to stop a train, then he's going to, there's going to need to be some friction there. Let's see here. We got this train. It appears to be moving quite quickly. So we'll say, there's definitely some kinetic energy there. At the end, there appears to be none, right? Not moving, so no kinetic energy. Not up high, so no gravitational energy. No spring, so no elastic energy. So what I'm going to do is I'm going to put the train in the system, but I'm not going to put Superman in the system. And the reason I'm not going to do that is because if I don't put Superman in the system, then I can just have the energy leave as kind of work out, and as energy lost, and I don't need to kind of deal with that. So obviously the train is going to start out with some kinetic energy because it's moving, and then we'll just say 1, 2, 3. All that energy leaves, and it goes to Superman. So, and then I don't need to kind of keep track of like what kind of energy they have. All right. Obviously, you were supposed to do number 9 on your own. I can't really, go over that in class, but hopefully, or in this video, but hopefully, kind of you can now grade it yourself after watching this video and seeing how to do these. Okay. Thank you very much for watching. Have a good day. And as always, let me know if you have any questions.